Why is formulae so important? Why does it matter so much in a chemistry exam to get all these formulae correct from the start? I'm going to give you all the tips and tricks you need at the moment to make sure you're getting a head start on the exam paper by knowing how to write systematic names and also get those formulae right first time. Hi everyone and welcome back. So, what we're looking at today is formulae. Formulae is one of the exam board's biggest kind of bugbears. They say that people are constantly getting formulae wrong, and those are the candidates who end up with the lowest grades. So it's very, very important if you're just starting out your A-level to make sure that you get these formulae done at the start. It's things like knowing that group 1 metals will be 1+ when they're in formulae, and that group 2 metals are going to be 2+. Transition elements have various positive charges, and they're always positive. And you've also got some variance in your non-metals. A lot of people forget that the halides of chlorine, bromine, and fluorine, don't know why I did them in that order, but there you go, they're going to also have the option of having positive oxidation states. Oxidation states just means charge, so they can often be positive. Now, that's a bit confusing because when you first learn about the halogens, you learn that the halide formula, which is the X-, is always just that, a minus. F-, Cl-, Br-, and I-. What you need to be careful of is that they can also be positive. So how are you going to be able to spot that? Well, if they give you one of the formula in the exam, they might team the chlorine, the bromine, occasionally iodine, but it's less common in the exam, that's why I'm not really covering it. They will team it with oxygen in a formula. Now, when you've got a halogen in a formula with oxygen, the halogen is going to have a positive charge more often than not. I can't say that's going to be the same every single time, but whenever you see a halogen in a formula with oxygen, it's going to have that positive charge. And it's also often teamed up with metals in there. A common one, for example, is sodium chlorate 1. Now, sodium chlorate 1, that little 1 at the end, tells us something about the formula. What it's there for is, and the reason why it comes at the end, is it's telling us that the halogen that's inside that formula, the chlorine, has a 1+ charge. It's pointing out what that charge is because it's breaking the norm. So watch out for those Roman numerals at the end of a systematic name because they will tell you if the halogen has got a non-traditional charge, and remember that those Roman numerals are always referring to positive oxidation states. The other elements that get these Roman numerals are the transition elements. The transition elements can have various oxidation states. That's what makes them transition elements. There's loads of other stuff involved in that, but that's all part of your A2 course in transition elements. So, when you see the Roman numerals come directly after the metal, the Roman numerals are referring to the metal. So iron 3 means the iron has a 3+ charge. It doesn't mean there are 3 ions in there, and that can sometimes look a bit conflicting in the formula. So a really complicated example of this then, from the start, would be something like iron 3 chlorate 1. Now iron 3 chlorate 1 would have the formula Fe brackets ClO and a 3 outside the brackets. All that's going on in there is the iron 3 tells me the iron is 3+, and the chlorate 1 tells me that the chlorine inside the ClO minus is the ion, is going to have a 1+ charge. The 1 doesn't tell me that the ClO is 1-, it's telling me about the chlorine in there. And so you've just got to do a little bit of jiggery pokery knowing that oxygen is 2- in 99% examples. Now, these rules can be flexed around a little bit, but it is crucial for you to know them and to understand when they change and when they don't. And it's all about practice. I would really encourage you to go through all the work you get and go through a textbook and make sure you can not only name formulae, if you're just given the salt layout of it, for example, but also make sure that you can go back from the systematic name to the formulae as well, using those Roman numerals where appropriate. I hope that clears up some of the formulae tips and tricks that you might need starting out your chemistry A-level, and don't forget about those systematic names. I'll leave you to the rest of our amazing playlists and videos, and until I see you again, happy revising.